And the last, like what are the use cases and the decision frameworks, when do we actually use that or not. So this is a quick uh, what exactly that we are covering over here. So if you guys are comfortable, just to I'll just turn off my camera and so that you guys can focus on the PPTs itself. Okay, cool. So yeah, that's what we are covering today. And so now what exactly is the like the AI landscape and context. So like we were talking around, like why is everyone talking about AI agents right now, right? So it's primarily like very obvious because system couldn't talk, right? Like I said, but but they could, can truly act around if we try to give the access to the agent with the specific tools and like everything. So what exactly happens in uh, like the entire agentic flow. I'm just giving you the brief around them. So it's kind of a foundation model that we have. So imagine, like we have any of the applications that is like that could be anything like enterprise software or anything. And uh, and then like there is a, like where exactly like the Nemo kind of a sits, I would say. So this would be consumed by the Nemo, like the agentic toolkit. And then there would be a kind of orchestrator. And like maybe I can just try and explain to you guys. Okay. So we have any of the, like these kind of application that we have. So this could be like application, and on the top, like that would be consumed by, I would say, like a Nemo layer, I would say. So that would reside where, like we would be building, we would be observing, we would be also evaluating and deploying the systems. So this is where like Nemo sets, like NAT sets. It's Yeah, and then this particular like the Nemo agentic toolkit, this is a orchestration, and this would be this layer is would be inside them. We can use any sort of like the agentic frameworks that could be like LangChain or like the Crew AI or like anything, right? So here this would be a kind of uh, yeah. So this would be kind of an agent framework. And then it comes like a model serving layer. So that could be like a NVIDIA NIM or like the OpenAI API, anything like that would be a kind of an infrastructure, like the inference infrastructure that would be we'll be having. So this layer could be a um, yeah. So this would be a model serving. Okay. And then there are the foundation models that would be, like will be serving, that would be uh, anything like could be a GPT-4 or like a Llama 3 or like Nemotron, anything like Nemotron is kind of Nvidia's model, I would say. So yeah, so that would be on the top. Yeah. So this is how it's primarily how the stacking happens, and so basically we have like the three waves of AI in the enterprise. So first of all, there was a in the first wave there was a rule based of AI. So which was happening around 2000s till 15 years, like 2015 I would say. So it was a kind of a rule based. When I say like rule based, that was a if then kind of a decision, like like the expert system, think it of a kind of a chatbot that understands just the keywords, and like work for like simple or maybe narrow tasks that we have. So the problem was it was very restricted. It could be just a if else kind of a condition that we can have a rule based kind of a chat. But in the second wave, it came to be as a predictive ML, which came around, I would say, like 2015, till when like the Chat GPT came around 2022. So where like the machine learning models trained on like the data to predict like what was the outcome. So it could be kind of a fraud detection, it could be recommendation system, it could be like image recognition, so many more kind of things. So that was very powerful, but it requires some sort of like massive like data labeling, because if you might have heard around like a fine tuning might require some lot of data, and maybe if you're moving ahead with supervised learning, there is a lot more of data that is required that has to be labeled, and also like a specialized engineer and the separate model for every different task. So that was when like we have the predictive ML, and the third way was like the foundational models with the agents that we are right now like having. So uh, like over here, like foundational model that we were talking about, uh, like the GPT-4, or maybe like Mistral or Nematron, anything, right? So this was a kind of one of the large model capable of understanding like the language. It also understand like the reasoning or like the coding, or maybe like what tools has to be used. So the agents kind of wrap these models to take like like take autonomous actions, I would say. And this is where like NAT operates, so helping enterprise to have like the reliability over the system, and also like the scale, and what's adding the observability, like what tools have been called, and etc. So uh, what actually has shifted fundamentally in like 2025, like 2024 to 2025, I would say it's from single model to kind of a multi-agent, I would say. In a real Because if you can think that the real enterprise task has like a very complex, it's not just one agent. So it's a team of specialized agent that kind of collaborates, and like are now kind of standard architecture that we follow, and not the experimentation. So uh, and also from custom, like there are many more like the protocols that have came, like MCP or like agent to agent, that have emerged as a universal, like the standards, like HTTP for web maybe, but for AI agents, talking to tools, and like talking to each other. So that's when like these agents have been becoming popular. So that's just to set the context, what exactly uh, are the agents, and how the things evolved around them. So from the chatbot to agent, it's a kind of a big leap, I would say. So uh, understanding like what makes like the AI agents fundamentally different from the chatbots, and why that difference changes everything. So let's just start with what uh, with what like the chatbot actually. So like, I hope like you all guys might have like seen how the chatbots work and like how they respond, right? So a chatbot is at a core is a kind of a LLM, I would say, that is wrapped in a kind of a text output and like text input and output like the interface. So uh, yeah. So, sorry, I was not changing the slide. So, yeah. So, like, I would say, like, you type something and, like, the model generates, like, a response, right? So, and that's done. So, like, the LLM is, like, I would say, like, a person who has read almost every book, every website, or maybe like a document that were present, and their knowledge is kind of a very vast, but it is also like like completely frozen, I would say, at that particular moment of training, because after the training, like the person, maybe like assume like the person goes into the room with no window, no phone, no internet, right? So think it in that manner. So they have a very limited information on which like these have been trained. So that frozen in the room quality creates like the four fundamental like limitations that make chatbot as a unsuitable for most of the real business tasks, I would say. So yeah. So that is because, sorry, yeah. So this is because there's no real-time information, because like the trading has a cutoff date, and ask about like the today, maybe like if you ask around like the today's stock price or like maybe yesterday's news. So you will get like either hallucinated answer, or maybe like if you have a proper guard railing or anything, then you can say like if you don't know the answer in the prompting, then you can say like I don't know, right? So that's in the real time information, and there is no actions also. So like a chatbot can tell you like how how to book a flight, but it cannot actually book the flight, right? So it can draft the email also, it cannot send it. So that's where like we have a gap around like the actions. And there's also a problem of like there's no persistent memory. So maybe like within a conversation, or like a chatbot kind of remembers uh, like within a conversation, I would say like the chatbot remembers like the moment the conversation ends, like everything kind of vanishes. So there is no persistent memory, it can't recall like what exactly that you asked like in the previous chat or anything. So it don't retains like any of the memory. So it doesn't know like who are you for the next time, or like what kind what project you were discussing, or like what decisions that you made. So there's no persistent memory. And the next is like a hallucination risk that we were talking about. So when I say like hallucination risk, it's primarily like when it doesn't know something. So instead of saying like let me look that up, it would kind of generate like a plausible sounding, or like a, maybe like the wrong answer, I would say, and with no ability to verify. Because the best thing is when you ask the chatbot or like question anything from the chatbot, you can also ask for the references or the sources based on which uh, that particular answer have came up. So yeah. So so there is a kind of a glass box kind of analogy, I would say. Like a chatbot is like, I would say, like an incredibly like a well read consultant that is logged in the like the glass box. You can kind of pass notes through that slot, but they can like pass a brilliant answer back also. But they cannot make a phone call, like open database, or like maybe Excel formulas or anything. That's any action from the outside world, I would say. So no matter how intelligent they are inside the box, but their usefulness for the real work is fundamentally limited. So yeah. So what actually make the agent different is like assuming like the agent is a kind of a same LLM box, but not a glass box this time. It's kind of open. So the agent has been given like the tools, for example, like the ability to call functions, maybe like the query database, or maybe like browse the web, or run code, or send messages, etc. But the tools alone are not enough. what makes an agent like a truly powerful is that because the reason about which like the tool to use, in which order to use, and based on the task it handle, without being like explicitly like programmed for any each scenario, I would say. So LLM kind of a reasonably it has the capability to call any of the function tool based on like whatever response like the agent or like the LLM has given, and based on that taking like the actions around them. And also they have like the persistent memory. They can kind of recall what exactly did you. So there are two types of memory that they have. So that's one is short term memory, then the other is like a long term memory that stays with you, and kind of a personalized with what exactly the user prefer. For example, you guys might have noted, right? uh, whenever you ask like a chat gpt for any respective code, they will return you whatever you have preferred in the past, I would say. So let's say if you ask the ChatGPT to like provide you a Fibonacci kind of a series, or a program. So it will, if you prefer the Python language, they will they would kind of respond you in a Python code rather than giving you a Java code or maybe like a JS code, anything, right? So that's the beauty of that. And then yeah, so the next thing is kind of a React loop. So this React loop is like it's kind of a pattern, like I would say like how actually like the agent think and kind of acts. So just to give a brief around them. So it's a kind of a the dominant pattern for the agent reasoning that is primarily called the React, which stands like for reason and act. It was kind of introduced in like 2022 in a research paper, and now is now like a foundation for every production AI agent. So like the idea is very simple and powerful, but the alternate between thinking and doing in the loop until like the task is complete. So for example, uh, step by step, if we break down, so let's say like the user there's a user goal, and the goal maybe like the thought is like what do I need to do the next, what information am I missing, right? So that's exactly like what's the thought that they have. But like I need a gold price in USD first, right? So the next thing would be a kind of action, right? So like calling like the tools with the specific input, like for example like the prices of the gold or like get commodities. So these would be a kind of functions or like the actions that we have created. So this could be like anything, maybe search web, like a latest Nvidia earnings or something, right? So this is primarily to call a tool with a specific input that the user have given. And the next thing is observation. So like reading the tool's output and add it to the context. So like the observation is like maybe they return like the prices of the gold, or so what exactly is the output that we have got, and we are also adding into the context over there. So and then like there would be again like a thought. So now I need uh, the USD to INR rate. Then again there could be another action, right? So that could be a get exchange rate, right? So any of the functions that you apply. So for example like get commodities, get exchange. So these function tools are called on a fly, and then also like there's a observation, and then the decision happens over there. So like do for example in this, do I have enough to answer? If no, then again like there would be again like the thought, then action, then observation. So this repeats until we have got like the final answer that we need to. So if you if you can recall, if you ask any complex queries to any of the LLM, maybe ChatGPT or Claude, right? So they kind of go through the web pages, understand like the what information have been collected, then get some clarification questions from the users, and then again reiterate over a few of the things. If they think now that's the final answer that's gonna they're gonna roll out, then we get the final decision that yes, we have all the things in place, and now that's the final answer to deliver to the user. So I would say like a real the React trace watching like in a loop action. It's like tracing what exactly let's trade let's kind of a trace exactly what happens when the user asks. So in this case, like we understood like what the use what's the today's price of the gold in Indian rupees. So the third one would be kind of a user uh, wants the gold price in INR, right? It doesn't know like the today's gold price. So my training data is not in a real time. So I need to look it up, right? So I'll use like the commodity price tool again, right? That's the thought process. Like next, the action would be it's gonna call like the get commodities price, and like the commodity is gonna be the gold, right? Then maybe in the first observation we get the tools returns would be like the price. There is maybe like a to 2380 USD, right? And then uh, so similarly, like we return any of the first observation. Now like the second thought would be like if I have the USD price, but the user wants the answer in INR, maybe that API.
This meeting is
Observation,
being recorded.
and then we get the final price. So the agent is not a chatbot with some API call. So it's a kind of a reasoning system, I would say, that uses like the tools as a extension of the intelligence, deciding when, which, and like how to use them based on like what actually the task requires. So this is a fundamental shift from AI that talks to like AI that does it, and or like the perform actions. So what exactly this agents uh, so uh, these agents are hard to build like a reliability, because I would say like there are few common problems with the agents in a real engineering, I would say. So this is where like the NAT is specifically like designed to solve. So first problem is kind of a non-determinism. So it's kind like the query, the same query can produce like the different plans on a different run. So maybe like if you first time you ask any of the question, any particular question, the agent might have returned you a different answer, and the next time it might have returned the different answer. So that's a kind of a non-determinism, right? So it makes like the testing and debugging like the fundamentally harder because than the traditional software, because uh, traditionally, if you can think, if you give like one particular input, of course like there's a chance, there's 100% reliability that you'll get the same answer every time. But the agents are a bit different. You get a non-determinism. So every time you ask, you might get the different answer if you don't follow like or like do some proper engineering on the top of that. So the next is like the tool failures. So if a tool kind of return like an error or maybe like a bad data, the agent may produce a wrong answer, or there is a loop like infinitely, right? So the error handling must be designed very carefully. Another thing you guys might have heard around, like what we have a context window limits also. So where long reasoning chains consume a lot of tokens quickly, right? And complex tasks with many tool calls can fill the context window and can cause failures. So there is a limitation around like the context window. For that reason, there is like a long term memory, short term memory, and of course like there are some models which have a larger, the context memory. But again, there is a trade-off. So the models with a larger context memory may have long latency, a higher latency if comparing with the shorter context memory. So and there's a problem of infinite loops also, without, like, if without a max iteration guard, if you poorly kind of a design the agent, it can go on the loop forever, burning like the API credits, and you wouldn't get any of the insights. And the last thing is observability gap that we have. So when an agent, like, gives the wrong answer, how do you debug it? Unlike a program that, like, crashes with the traces, and the agent failure requires replaying the like entire reasoning chain. So it's bit hard with the agents to reproduce that same scenario. So yeah. So I would say, yeah. So now, like, what exactly is the enterprise, like, AI problem that we have? So why building agents in a real business, like, uses like a 10x harder than building for a demo? So there's infrastructure gaps that actually NET fills. So I would say, like, to add to this, like, what exactly like the NAT is providing is, like, it's provides us as the security, like, the production agent needs some sort of like the authentication, like who is calling, authorization, like, uh, what are they allowed to do. So, and also like the protection against like that adversarial attacks, like the prompt injection, jailbreaking, or like the data exfiltrate. So this provides us like the security, this provides us like the observability when, when something goes wrong, maybe at maybe 2 a.m. On Saturday, right? You need the logs and the traces and metrics that allows you to understand exactly what agent did. So and also like why it failed and how to fix it, right? Without this, you are flying like blindly. So this requires observability, and also like the quality assurance. So how do you know like the agent is giving the correct answer? And how do you catch the quality, the regression when you update the model or change the prompt, right? So what you need a systematic valuation around it, not kind of a manual spot check. So we require some sort of like the quality assurance. And the next thing is the performance. Like the user may expect like the fast response, but LLM calls are kind of a slow and expensive, as we know, right? So we need kind of a profiling to find like the bottlenecks, and to kind of make this to the next level. We kind of also use some sort of like methods like caching to avoid some sort of like redundant calls, or like rate limiting to protect like against any overloading. So if anybody is trying to abuse that and like making random, or like uh, have created a bot that is doing a multiple hitting like the API again and again, right? So there has to be rate limiting also. So it's entire system that we make. So, and the next thing is reliability. Like the agents in production must handle like the API, like the timeouts, and when to have that proper timeout, and what are the tool failures, what are the model errors, and unexpected inputs, so gracefully. So it should not crash and leave the user, like with some confusion, like what are the errors. So and also the next thing that is provides is the compliance. So enterprise needs like the audit trails, PII, like the security, and like the data residency control. So and the ability to prove to legal and compliant team exactly what the AI system did and why. So just to simplify this, so I'll just imagine, like we're building like the demo agent. Building a demo agent is like like cooking a meal or for the friend at home, right? So uh, you can kind of improvise, make mistake, and it's fine. But running a Michelin star restaurant, serving 300 covers a night is completely different, like challenge. So you need a standard recipes or trained team, like the functioning of like a kitchen and a health inspection, reservation system, or many more things. And when you're dealing with the scale, right? So that's why exactly this Nemo is required. And uh, so there are other, like the major enterprise challenges with the AI framework landscape has also exploded. And like the different teams within the same company might be using, let's say, the lang chain. There are different frameworks. So for example, like the lang chain, like crew AI, the autogen, the Python functions. So what exactly these are good for? So I would say, like for example, like the lang chain, it gives the rich ecosystem, like many built-in connectors, maybe like the rack supports. But what it lacks is, it lacks, like there is no built-in evaluation, or like no standard deployment, and no there's a heavy abstraction, right? And similarly, maybe the llama index, it's excellent, like the rag and document indexing and etc., right? But the limitation is, like it's limited multi-agent support. There's no production server. So everything comes with the limitations as well, with the new yeah. Okay. So uh yeah, I think like these are the four things, basically, like every enterprise AI team should that requires as kind of like having a the build a unified way to build and connect, and like version agent system, regardless which underlying frameworks that we're using. So uh, which actually like NAT workflow YAML config provide this. And similarly, it provides like a full tracing, token metric, latency, like profiling. And uh, I would say it also helps us to evaluate like a system quality measurement with the test data, maybe like the multiple metric type, or like the A/B comparison. So hope you guys are following, right? I mean, if any question, you guys can raise your hand, and I can address them. So just give me the heads up if you guys are following till now. I'm trying to simplify this session as simple as I could. So just give me the heads up if you guys are following. I'm assuming like no question till now. I can just proceed, right? Okay. Uh, yeah. So what exactly is like a NAT? Is it's kind of a NVIDIA's like an emo agentic toolkit. I would say like NVIDIA, it kind of builds and it is kind of a build and maintained by NVIDIA for sure. And like a Nemo is a kind of a NVIDIA's broader, like AI framework ecosystem that originally, like focused on speech and language models. And NAT is a kind of focused branch of the Nemo family. And agent specifically built for the agentic system, not just the LLM generation. The entire design is oriented around like the agents that that reasons, use tools, and take actions. And the toolkit, a complete set of you know like uh, like no a complete set of tools, and not a single narrow library, I would say, that covers like the full life cycle, that builds, that observes, that evaluates, and also deploys. So in one sentence, if I had to say, like NAT is a kind of open source, like library for building, observing, and evaluating and deploying AI agents, regardless of which framework those agents were built with. So that's a very important point. So NAT actually is a kind of a orchestration and a management layer for agents. So like the framework agnostic, like whosoever works with LangChain, Crew AI, etc. Right? So uh, it's a kind of a config driven, like a workflow system where we have like the workflow.yaml file where like everything has to be in a systematic manner. There's a formal pattern or like a format on which we used to write like the workflow.yaml. And then we can also attach some sort of like the observability layer, which could be maybe like the open telemetry or like OTel tracing, anything, right? And then it's also like a kind of evaluation. It provides like an evaluation framework for the agent quality. It's also open source, and like it also is compatible with any of the LLM. So whether that's NVIDIA NIM or like OpenAI, and it also provides us like the deployment toolkit. So what people usually gets like confused if we can replace like the NAT with the Lang chain or like Crew. So NAT is not a kind of a replacement of a Lang chain or Crew, eh? Uh, or like it's also not a LLM model itself. Um, wh- uh, so, like, what exactly NAT is, like I told you, like it's a kind of orchestration and a management layer. So, anything that the tools that you guys have been using, it's you can use them in place. But to just to bind up all together, we kind of use NAT for that. So it's not competing with LangGraph or like AutoGen, or not also specific to one industry or domain. Not a cloud hosting service, I would say. So yeah. So uh, the like the three sessions of every NAT flow, like the workflow that we have is like that's that's a functions for example, like no matter how complex is defined by a like a single workflow YAML, the file always has like the top level sessions. So understanding three sessions in a foundational understanding would be kind of functions that we have. Another would be a kind of LLMs, and the third would be a workflows. So the functions would be like the tools or your agents can use. Like that could be a Python functions, that could be database queries, that could be a like the API calls, web search, or like RAG retrievers as well. And LLMs could be like the language model that provides your agent which model, which provider, what temperature, or like how many tokens, right? You can define multiple and the next is kind of a workflow. So the agent type and configuration, which like agent pattern to use, or like it's a React that we discussed initially, or a router or sequential, which tools it has access to, or which LLM powers and how actually it behaves. So just to give you like like how exactly this workflow YAML looks like, maybe I'll show you guys. So workflow dot YAML. Okay. So if you see over there, so these are the functions, right? So the functions could be like a Wikipedia search. The type is, like we have like a wiki search, the max results. So likewise, we can set the different parameters. So what LLMs have been we need to use. So here I've used like the NIM, what like the model name, and also like the temperature that has to be, if we set like zero point 0.0, that is more deterministic, and how the workflows has to be designed. So the type is a kind of a agent, React agent. The tool name is Wikipedia search. So likewise, we have a proper like workflow YAML. So it's not a kind of a Python code, not a boilerplate, I would say. And so the agent is defined entirely in this YAML. and NAT handles everything else, like loading the models, registering the tools, running the React loops, or like returning like the answers. Yeah. So this is how it looks like. And so the config driven philosophy, why exactly it matters is like NAT's decision to use like the YAML configuration as a primary interface is a deliberate, like the architectural choice, not a convenience features. So here's why it matters like deeply, because uh, we need a separation of logic from the configuration, because like your Python functions contain like the business logic, right? The YAML describes how they connect. You can change like the agent, how agents are kind of wired without touching the business logic. So any different model you want to try, so that's the reason why we are using like the YAML for that. There is also like the version control for each behavior. So because behavior is in a YAML file, you can you can get maybe like a git diff. Two versions of the agent system can clearly see like what have been changed, like just like comparing like the two config files, right? And also like the A/B testing without like the code change, like the creating the two YAML files with the different models or like the prompt, and run like the evaluation data set against like both, right? And pick like who's the winner, and all without modifying like the Python code. It also helps us to accessible like the two non-engineers also, because like the product managers and the domain expert can read and understand like the proposed changes on the config YAML. So they cannot read or understand like the Python orchestration code. So I think like for that reason we're setting this config YAML, workflow YAML. uh, yeah. So like the NAT architecture, coming to that bit. Yeah. Basically like how are they connected? So I mean, uh, like we discussed around like the full NAT architecture in layers. So first of all, there would be a kind of input layer, and there's gonna be the workflows that reads uh, the workflow YAML, builds the agent graph, manages the execution, which uses like the agent runtime. So like runs in a React loop, or manages like the iterations, handle like the tool dispatch, which also calls the different component layer, like the LLMs, the tools, the memory retrievers, etc. And then on the top of that, there is a and all instrumented by the kind of observability layer, I would say. So for that, we can use like the open hotel span or like open telemetry, things like that. So basically, like NAT kind of reads our like the YAML file that converts it into like the Python dictionary. So uh, every intended session becomes like a kind of a nested dictionary. So the YAML, uh, I would say like that has to be a proper, like a YAML file. There should not be some sort of like the syntax error or anything. So um, I think like we have covered this. Okay. I can give you like the brief, like what exactly, although like we have covered this, like when exactly like the lang chain have been uh, need to be used, and what exactly is the NAT relationship. Maybe we can discuss around them also. So NAT versus other frameworks. So like I was initially we were discussing around like NAT is not a competitor of like any of the lang chain or like a lang graph. It primarily uh, strongens the bond, or like I would say like it creates the it binds them together, I would say, to be more accurate. So for example, like if you're using like the lang chain, right? So like we were discussing like building individual LLM chains and agents with a rich library of the connectors and the tools. So what exactly the NAT relationship holds with a LAN chain is like a LAN chain is an agent executor, and it can also wrap as a NAT function, maybe a tool that adds like some sort of like the observability to it. So similarly, we have for the Llama index, the Llama index queries, like the engine can be wrapped as a NAT retrieval tool. And so every different tool or the framework that we're using, NAT provides that connectivity and enriches like the entire system. So that adds a lot of features, a lot of observability. It's easier to trace and reproduce, I would say. And so yeah, so um, so assume a building analogy is the LAN chain or like the Llama index. It's kind of like a brick and a cement, right? And like from the construction analogy, I would say. So the raw building material for making like individual agents and racks, and like the crew AI or like the autogen is kind of an architectural blueprint, like which follows like the pattern for how multiple agents collaborate and divide work. And now like the NAT is a kind of I would say like a construction manager, and with a building inspector, with a property manager that makes sure everything is built correctly, inspects quality, and manages like the building once it's occupied by the real users. So you all need like three. NAT doesn't replace the brick. Like it makes sure like the building actually gets built and stays standing. So that's kind of a supervision, or like adds some sort of like extra metadata that's very important for the production level. So um, now the question comes like when to reach for NAT versus like just using like the frameworks directly. So when exactly do we need to use the NATs? So like basically when we are building any production level or like the real user, or like working with the real data, right? When we require some sort of like the when we require to add some observability to the agents, what agents are doing, then we require NAT. We also need to measure like the agent quality systematically, then we require NAT, right? uh, we when we had to communicate via maybe like MCP or A2A protocol support, or maybe we need some sort of like deployment with auth or like rate limiting. There's no custom function that we need to like add on. We can directly like use NAT on the top. And when we can skip like the NAT is when we do some sort of like the rapid prototyping. Never that's for the experimentation, not going into production, or like using like the simple single agent with no multi framework complexity, or like then we can like you're still deciding which LLM or framework to use. We can kind of avoid like NAT over there. So the thumb of so the rule of thumb is uh, we start prototyping with the LangChain or like the raw Python, and when you're kind of ready to make it reliable, observable, and measurable and deployable, wrap it with an app. And the migration is usually a few hours or minutes, and not a kind of complete rewritings. And also like I think like the Claude can help, or like uh, yeah, the Claude can help you guys, and like wrapping it around few minutes, I would say. uh yeah. So now let's go to like the pillars. What are the seven core pillars of NAT? So uh it's like I hope you guys understood like what exactly the LLM, like the large language models are, and like what is the tokens. I'm not just deep diving in and all of the stuff. Just to set the context, I'm giving you like this heads up, like what exactly is the LLMs. I hope you guys know. Like tokens, similarly, it's LLMs do not like process like the letters or the words. They kind of process like the tokens, right? So tokens is a kind of a chunk of text, roughly maybe like 2 to 3 characters. So it depends on like what kind of tokenization techniques that we have. Not deep diving into more detail around like how tokenization techniques happen, or like what are the different techniques, but just to set the context. So so the next is NVIDIA NIM. So NVIDIA NIM is kind of a inference microservice that is provided by the NVIDIA for hosting and serving the LLMs. So uh, yeah, okay. So yeah, so so basically it provides like the optimized and like the optimized hardware accelerated model inference on NVIDIA GPU. So it could be used in both like the cloud and like on premises all as well. So what are the key properties of NVIDIA NIM? So, like it's OpenAI compatible API. So NIM use like the same API format as OpenAI. This means like any code written to OpenAI works with NIM with just a URL and a key change. And the broad like a model catalog, like the I would say like the hosting, like the Llama 3.1 or like Mistral or any other model, like the free tier at like buildnvidia.com with like we have 40 requests per minute as a rate limit, so we can also use that. There's no GPU required for APIs when using like the hosted NIM APIs. You can code your code can run on any machine. NVIDIA infrastructure like provides like many like the GPU computes, and also we can have like a self-hostable. You can download NIM Docker containers and run your own NVIDIA GPUs for like complete data privacy, or like there's no rate limit around them. So um, yeah. So these are the few things. So coming to the configuration, configuring like LLMs and that. So like we were discussing around what exactly was the workflow.yaml looks like. Uh, uh, so workflow YAML is where you define like the model to use. So we can define like the multiple and assigning like the different ones to like the different agents. Maybe like a small small fast model for routing, maybe like a large powerful model for deep reasoning for that. So likewise um, we can have like the config YAML. We can set like this. Oh, sorry, workflow YAML. So like for example, like the faster LLMs, we can use this, and in order to have the deterministic like the answers, we can set the temperature 0, and what should be the max token. If you want some deeper task or like some complex tasks, you can use some better model like 70 billion instruct model, and increase the temperature, increase the max token, and there could be some any other model that you require. You can always you can create a like the workflow YAML, and accordingly you can set like for which use case which model have to be used. So here, if you can see, like there is a temperature also, right? So that's a kind of a single like the important parameter, I would say, because temperature controls how random or like creative like the model outputs are. So it's a kind of a number between 0 to 1. Understanding understanding like it is critical, but like building the reliable agent. So if you say like zero point 0.0, it's kind of a more deterministic. It's like always picks the highest probability next token. Same input means like same output every time, like we were discussing. So using this for the tool calling, maybe routing or like the factual reasoning, where consistencies matter, right? So we kind of make temperature as 0 when we require the balanced output, like some variation, like we can set some value around like 0.3 to 0.57, maybe something like that. But generally, like coherent and on topic. So that's primarily useful when we have a when we're using that for the conversational agent or like a general purpose task reasoning. And when you want some sort of like the creative answer, we can set that to zero point 0.8 or like or 1. That's a high, like a variation. Sometimes we have a kind of a we get the creative answers or writings, maybe sometimes when we are kind of a brainstorming and also like generating like a diversified options, right? We and never use for the tool selections, that is for sure. Because I mean, if you use the higher temperature for the tool selection, it might like we can call the different tool, and uh, uh, that could be difficult for the production level kind of a system to tackle. So the common mistake that we have is, we use like using like a higher temperature for the agents that like called stool. So high temperature, like we were discussing, we like makes the LLM unpredictable about which like the tools to call and when, like leading to inconsistency, hard to debugging behavior, keep tool calling agents at. So whenever we have to call some tool, do some tool calling agents, we generally use a temperature as zero point 0. So that's how. Yeah. uh, So I think like we discussed around like the workflow YAML as well. So maybe we can deep dive in a bit more into this, like the workflow.yaml. So it's primarily like the config system, I would say. So like that have every session, every field, and why like the config driven approach, like it's kind of a very powerful. So every NAT agent is completely defined by the single YAML file. So this is a single source of truth for your agent's behavior. So uh, like change this file and you can change the agent. So like version control this file and your version, version control, you can have a different version control of this particular agent that you have. So like the file has up to like 7 top level sessions, uh, through only like 3 are required for the basic agent, I would say. So like uh, I would say like the first one would be like the functions that we have. Like the other would be a kind of LLM, which language model to use. The third would be a kind of workflow, like a routing agents or like a sequential or like a React agent. Uh, the other section could be a telemetry, like what are we using for that, like a logging mechanism like the OTel or maybe like open telemetry. What server are we using, like it's a kind of UV-conf server or anything else, like the fast API or something, right? So why actually like the YAML? Why are we using like the YAML, not a Python code? So you might wonder like why not just write a agent in the Python directly, right? So many frameworks let you do that. So like a NAT config first approach has a specific advantages that becomes very clear at scale. So I think like the like we were discussing around like the reliability for like the non-engineers, like the product managers, solution architects, might not understand like the Python orchestration code very well. So, but that's easier for them to understand like the YAML file, understand what exactly like the agent does and what tools it has. So, it's kind of a readability for the non-engineers. And the next is like a safe experimentation. So, to try like the different models, like change one line and to add new tool one, like one block. There's no risk of introducing like the Python bug while making the configuration change. And also that's a environment specific configs. So you have like a workflow, like a dev.yaml, you can have a separate, you can have a workflow underscore prod.yaml as a different, without like changing any single line of the code. So just the config YAML, the difference you can have a create like a different agent for that. And that's also like the programmatic generation. You can generate like a workflow.yaml files programmatically, and it's also useful for creating like the customized agents uh, per customers, per use case, per environment, I would say. uh, so yeah, so I would say like the nats, we also have like a there's a type field that you have seen, right? So the type field is how actually like a nat knows like what python class to instance for each component. Like a nat maintains the registry that maps, like every type string to the actual class. So that is why you write like the type underscore type as a React agent instead of importing or instance importing like the Python class yourself. So built-in types you'll use most of the times. So like the type value could be, like NIM when the category is LLM, or like when what it creates, it's kind of an NVIDIA and I'm API key. So similarly, uh, like a wiki search is a kind of a function that's a built-in Wikipedia search tool. Datetime is also a function that built in like a current date and time tool. So and React agent, like we discussed, is a workflow, like the React reasoning loop agent, right? And what else? Yep. And yeah, in the last, maybe like the lang chain agent, we can also, that wraps. So anything that we can have, we can write them in a workflow YAML in a very structured manner, like covering up all those uh, different sessions accordingly, and what type of function tools that we have, what kind of model that we are using, what should be the temperature, and each and everything could be written under the workflow.yaml. So yeah. Okay. So I think like the next is yeah, these are few agent types. Maybe we can cover it. Uh, okay. So I would also like to cover, first of all, like I think like the one thing that we missed is uh, like how exactly are these what is the theory behind, like the tools in the NAT, like how they are, or like how they work internally, how the tools and decorator works, and pydantic validation. So for example, let's assume there is a LLM output a tool called a structured JSON, right? So there's a tool that we have given as a get weather, or with the arguments as maybe like the city as a Delhi or anything, right? So then, like what exactly like the NAT does is it intercepts and validates like the arguments against like the tools, maybe like the pydantic schema that requires like the type checking, required fields are present or not. If that is valid, then like we call that the actual Python function with the validated argument that the user has given. So then the function kind of returns like the NAT serialized return value in a string, and appends like it to the conversation as an observation, I would say. And it like continues like the React loop. So either calls another tool, or maybe like generates the final answer. So without tool, like LLM is kind of a, like the frozen snapshot of like the knowledge with no ability to act. So like the tools are what transforms an agents to the sophisticated, like the text generator into a system that can actually do things. So NAT is actually a kind of a tool that simplifies the Python function that can be triggered in a function session of a workflow.yaml, and made the agent and made available to the agents. So how actually like the tool works, like we have explained. So now there's a tool like a decorator, like if you can see um, over here. Okay. Yeah. So tool decorator pattern, like that's a kind of cleanest way like to register like the custom Python functions to the NAT tools. So that's how we register like the tools. We can have any tool, any tool that we want to give, we can use this particular decorator function and register them into the as a NAT tool. So we can import directly from, like from Nemo agentic toolkit, import like a tool. And yeah, and also uh, I think, yeah. So basically, like for the good NAT tools, like we what we generally follow is a precise like a doc string. So if you see over here, like get a weather for a city when the user asks about the temperature. So like a LLM kind of reads those doc string to decide when to call that particular tool, and any of the vague doc string can, like lead to the wrong tool selection. So like a precise one, like get current temperature, use this when user ask about like the weather, that can lead to the reliable behavior. So like the doc string is like that, it has to be a very, like precise also, and uh, I would say like that, so that you can give the idea to the LLM, like what exactly have to be, which tool have to be called. And the next thing is like the pydantic input schema. So like the base model class, like defines exactly what input the tool accepts. So like the NAT validate like all those arguments against like the schema before calling the function. So this catches like the type errors, like maybe like passing the numbers when the string is expected, so before they reach out to your code. So it helps like LLM to understand exactly what to provide. So it is very important to have like the pydantic input schema. And also be very mindful when you like return errors as a data. So if your function kind of encounters like the error, right? So like user not found, or like the API timeout, or so return a structured error dictionary. So like over here, so return like an error with a particular message. So do not raise an exception. So like the LLM can read like this, maybe your message, maybe like city not found or anything, and can respond gracefully. So and because like unhandled exception can crash, like the entire agent loop. And yeah. So the next thing, the last thing is, like there's a single responsibility. So each tool should do exactly one particular thing. So do not build like the tool that searches like the web and summarizes and save to the database. So instead of this doing in a one single tool, I would suggest to have a three separate tools. Make tools a kind of a reusable, testable independently, and give like the LLM a clear choice about like which tool to use and when. So yeah. So like in this particular example, if you see like a wiki search where it provides like a Wikipedia search, like finds like the article matching the query. So maybe example use could be a fact lookup, or like a background research. Similarly, like a date time to extract like the like yeah, maybe like similarly we can create for the date time for any time zones what we require. Maybe could be used for AI news uh, uh, come out for this particular week. So this particular week we are signifying, so it's gonna look for today's date, and or maybe like today's this particular week, and can just go to the web and try to extract all those like blogs and information which kind of align that particular dates or something. Similarly, we can have a custom Python functions, you whatever business logic you want to write, or like DB queries you want to give. And yep, similar, we can also have a vector retrieval, likewise, like a RAG search over the vector database. It's search like maybe like the company docs, or like a knowledge base, maybe policies, and returns like based on response based on those documents. So the agent types, when exactly, when to choose which type of strategy. So every agent type like NAT provides is like what they are, how each one kind of reasons when to use which each, or like how to choose the right one. So what is the kind of a agent type, first of all? So agent type defines like a reasoning strategy, I would say. So like the algorithm that decides how the agent plan, act, and decide when it is done. So like the different types are like the different types are better for different situation, I would say. Choosing the right one is a design decision with a real performance and reliability, like the implications. So we were discussing around like the React agent in the previous slides also. So like React agent is mostly common use type, because it helps us to go through the thoughts, convert them to actions, and then there's observation loop we covered earlier, right? So the agent reasons out loud, calls tools, read results, and reasons again and repeat until it has like the complete answer and hits the max iteration limits. So when basically to use React, so for any open-ended task, when you don't know like in which know in advance like how many tools will be needed, or in what order, it's kind of a flexible and general. It handles like unexpected situation by reasoning through them. So that's when we use React. But what are the limitations? So it's kind of a slower for the task with a known fixed structure. So like each like iterations required LLM calls. Maybe so like five iterations is equal to five LLM calls, right? So you can get stuck in loops, and if like the tool returns confusing data, or like uses like the max iterations, right? So likewise, when that's when we that's a limitation of the React. So there is also a router agent. So what exactly like the router agent does is it does not calls like the tool itself. So its sole job is to read like the incoming query and decide the specialized agent should which specialized agent should handle it. So like each specialist gets the natural language description of its domain, and then LLM picks the best match. So like the analogy would be kind of the router as a is a receptionist at a large hospital, and when you walk in you don't go directly to the heart surgeon, right? So like a receptionist might ask you like what are you here for, right? And directs you to the right department. So the router agent, it's like a receptionist. So that's fast, that's cheap, and also like crucial for the like overall system efficiency. So likewise, you can also I'll show you how exactly you define the strategy is. Uh, So, like, you require a small routing technique, right? So, the fast LLM, you can also define the LLM, what to be used. And the agents are kind of a financial agents that is specifically for the stock pricing. There is a HR agent, there's a teach agent that could help you for any of the issues. So, different agents for different use cases that kind of redirects you. And the next is a sequential executor. That's a kind of a reliable pipeline, I would say. So like a sequential executor runs like a fixed, like the list of steps in a predefined order, and there is uh, like no LLM deciding what to do. Like, So these steps are very hard coded in the config. So like the output of step n automatically becomes like the input of step n+1. So this is a completely, like deterministic. So when exactly do we use like sequentialist? When you know exactly what needs to happen and in what order, maybe like a ETL pipeline or like a report generation where it fetches, analyzes, write, and sends. Like that's a format, and maybe like a fixed processing workflows. So that's when we use sequential. And like the advantage is because it's kind of a fully predictable, it's easy to test, and also like fast because there is no LLM reasoning overhead for planning. So and also that's easier to debug. So that's when we use like sequential. And I think like how do we actually choose the right agent type is like there could be various scenarios. Like for general Q&A, like unknown steps are needed, right? So then we use like a React. So because like that's a flexible reasoning for the unpredictable task. When we have like a multi domain chatbot, many specialists are present over there, then we can use like a router on the top of like the React workers. So like a router is a cheap, it executes specialized, and then there could be a React workers. And when, for example, when we know like the fixed data pipeline, then we can use simply like a sequential executor, because that's predictable, fast, and like a no reasoning, it's no reasoning overhead is there. In case of like research and like analysis needing like a deep thoughts, then we use like a reasoning agent, like a chain of thoughts for the hard problems, right? So and then there's a personalized assistant that kind of remembers you. Then I guess like there is a the best agent is kind of a like a auto memory wrapper kind of thing that adds like a long-term memory to any of the agents. So like the most common production pattern is a kind of a router agent that receives like all requests and routes to a specialized React agent, which like each with their own domain specific tools and prompts. So the router agents uses like a small fast model, like the worker uses like a larger capable models. This is kind of a cost efficient, and it scales well as well. So yeah, that is something. Just let's just take like a 2 3 minutes of break, and I'll just go and sip of water, and then we can just come back and resume the task. Just 2 or 3 minutes. Hope that is fine, right? You guys can also like take a 2 minutes break. Hello. Can we resume?
Yes, sir. We can hear you now.
Okay, cool. Perfect. Okay. So the next thing is, I think like the next pillar I would say is a kind of observability that we, like that we can add, and why agents are kind of agents are basically like invisible by default. So how kind of open telemetry tracing works, and like uh, what the spans or .json output from the slide, like if you can see, deck actually contains. So this is a span.json. So agent is a kind of a black box, I would say. So there's a agent black box problem. So when like the traditional program crashes, we get stuck. We get like the stack traces like file x line, like 47. There's a null pointer exception kind of stuff, right? So, but the problem is immediately located. And when agent like when AI agent gives like a wrong answer, like the failure is invisible. So you just see like the wrong output. There's no crash, no error messages, or like uh, no line number, right? So you don't know like if the LLM reasoned incorrectly, or like the tool returned like the bad data, or there's a prompt like the prompt was ambiguous, right? So this is like the observability problem. So, and it is one of the most critical challenge in the production AI. So like production AI engineering, so like NAT kind of solves it via open telemetry tracing. So automatically kind of wrapping every operations in a timed and a recorded span. So just to set the context, like what exactly is the open telemetry? Open telemetry is a kind of a vendor neutral, like open standards for distributed tracing, metrics, and loggings. So that's originally, like designed for the distributed microservices. So it turns out to be perfect fit for AI agents as well, and which has a similar complexity. Like one request flows through the multiple LLM calls, tools, agents, reasoning steps, etc. Right? So NAT implements like the hotel natively. So when you add like the telemetry block in your workflow, workflow .yaml. So as shown, like right in the deck. So like the NAT automatically wraps every operations on a hotel span. So you don't write any, like the tracing code. NAT does it for you. So that's very straightforward. So you just have to write this like one single block, and there has to be one the spans JSON where you need to write around like, so it's gonna record like in this particular format. So like in inside like the span.json. So yeah. So this is I would say like the telemetry, the format is like a telemetry. There has to be a login, and like output file that has to be defined, and for a span.json where like all the data, that particular file for all like the trace data, and then like the rest of your workflow is gonna be unchanged. So like followed by like the workflow, like the type should be kind of a React, and the tools, whatever tools are available to you, and things like that. So what the span.json file uh, contains, it's like it's a kind of a sample span from like output file, I would say. So uh, like Wikipedia search is basically, like which operations this span covers, how long duration milliseconds might be, like how long this tool call took, right? And similarly, like for the prompt, like tokens sent to the LLMs, and completion, there's 58, like the tokens generated by the LLMs, right? So Similarly, like input exact input that triggered this call, like output is exact output that was returned. So that's what exactly like the span.json contains. So like every details around them. So so what exactly like these four fields tell you in productions, like duration milliseconds, like a short span of duration milliseconds to find the slowest operations, right? If Wikipedia, let's say, takes like 842 milliseconds, your LLM calls takes 120 milliseconds, right? So the bottleneck is is a tool, not the model. So we have to optimize accordingly. So there's a like a token usage also, right? So multiply like prompt tokens into like the input pricing plus like the completion token into output pricing, right? So you can get the cost per call. So you can aggregate across all the spans, and you'll get like the cost per request, per user request, right? So spot which operations are more kind of expensive. This way you can get a lot of insights from this. Then there is a input, right? Input, the like see the exact text like that trigger each operation when the agent called the wrong tool. Like the input field shows exactly what it was thinking when it made the call, right? So similarly for the output, like see the exact data like the agent received from each tool. So like if the agent gives like the wrong answer, wrong final answer, check if like the output field shows like the bad data from the tool, or like the root cause basically, uh, root cause for many failures. So the first time I added like the tracing to one of my agent, I discovered like it was calling like the search tool four times for the same query, because it wasn't reading like the result properly. Without traces, I would have thought it was a kind of LLM quality problem, but with traces, I like immediately I with traces I fixed like in 10 minutes, and like that's a common experience from the NAT development. So so that's a heads up, like never ship like the production agent without tracing enabled. So because like the bugs in agents are kind of a very silent features, the wrong answers without error messages. So tracing is the only way to find them systematically. Okay. So the next is kind of a production and MCP, like a production deployment, I would say. So how NAT serve like works. So what authentication and rate limiting do, what like the built-in UI gives you, and so yeah. So like the gap between so the gap between it works on my system versus like production. So running like a nat like a running nat run like a file with a workflow.yaml with input with my question, right? So this works great for the development and testing, so with those parameters. But for the real production system we need much more, right? There's a multiple users calling like the agent concurrently, authentication to control who can like use it, rate limiting and prevent like abusing, cost overruns, and stable APIs. So NAT serve command provide it all. So like so it also provides like the server configuration block. So where like you just have to write the server, like the type has to be a unique UVCon, and what's the host port. And if you want to enable like authentication has to true, if there is a so if that's for the outside, the client must send some like bearer token, so that for the token, right? So if you see like what exactly you get from the NAT service, like I would say, like just to summarize this, we get like four production features. So one is kind of a REST API. So now your agent is like your agent is now callable from any programming language. any platform, any service, like send the JSON post request with maybe like the input, your request, and get the output, right? So there's no Python knowledge required for the caller. So this is what makes your agent like first class API service. And the next is like authentication. That is the bearer token. So for the request, for every request must include some sort of like the authorization, like a bearer, right? Your API token in the header. Request without this tokens are rejected in a 401 unauthorized response. So this means like you can control uh, who can use your agent. In production, you'd uh, use like a different tokens for different clients and rotate them regularly, right? So the next thing is a rate limiting. So rate limiting controls how many requests a caller can make in a time window. Without it a single without it a single like misbehaving client could like hammer your agent with a thousands of requests. So running your LLM cost degrading like the service for others. So NAT builds in kind of a rate limiting rate limiting requires zero custom code, just a config. So, and there's a professional UI also, the chat UI that it gives you. So NAT automatically, like generates like a web chat interface, uh, like uh, like a HTTP localhost 800 slash UI. So, for example, in the Swagger UI, you can write slash docs, right? So, similarly for this, you can write slash UI, and you will get uh, it can generate like a automatic web chat interface. So this is a proper conversational UI, not a like a demo toy kind of stuff. So it's useful for the internal teams to test like the agents, what for the stakeholders demos, or like for human in the loop workflows where someone need to interact with the agents via browser. So, why exactly UVCon is being used? So, NAT uses basically like the UVCon as a underlying web server. So, UVCon is a kind of a ASGI, like a asynchronous server gateway. Uh, Meaning like it handles like many concurrent requests without blocking. So this is critical for AI agents where each request might take like a several seconds while like waiting for their LLM response. So with UVCon, like like 100 users can call your agent simultaneously without waiting for the previous one to finish. So that's so like the entire deployment story, like it's a kind of a REST API, it's authentication, it's a rate limiting cache chat UI. So comes from like adding one server block to your YAML and running one command. No fast API code, no middleware, no auth framework. NAT handles it all. Yeah. So uh, So there is MCP and like agent to agent protocols also. I mean that actually like these are the basically like the two protocols that connects like the AI agents to the world. So MCP is for tools and A2A is for agents. So why they matter for the enterprises? Because like HTTP. So basically, let's come first of all. Let's cover like why protocol matters for AI. So before like HTTP was a kind of a universal web protocol, every website used to build like some custom communication protocol. Like two website couldn't link to each other in a standard way. So HTTP kind of solved this. So like a one standard universal connectivity. So AI agents world is going through the same evolution. So before like MCP and A2A, every AI tool integration was a custom code, and there was a lot of glue code also that we used to write on the top of that. So each protocols are creating the HTTP of AI agents. So MCP primarily was introduced by Anthropic and rapidly adopted by different industries, including NVIDIA and that, right? So it standardizes how AI model discovers and call tools hosted on external server, and MCP server is a process that exposes like a set of tools, like the function the AI can call via standard protocol. Any MCP, like a compatible AI, can use MCP server without custom integration. So, for example, just if I had to give you the example, without MCP, if let's say we have five AI platforms with 10 tools, there would be 50 integrations. So, 5 into 10. So, each integration, as you know, is a bespoke kind of a code. So, when the tool API kind of a changes, we have to update all 50 integration. And tool discovery is kind of a manual and a tribal knowledge. So like we have to do the changes in all 50 integration. But with MCP, if we have like the similar five AI platforms with the like the 10 tools, then we have like like it's kind of a 15 total implication, because like the tool implement like MCP for once and work with all the AIs. So when the tool changes, update only the MCP server. So it's like like AI auto discovers available like the tools from the MCP server. So in NAT, like MCP works in like the two directions. So NAT can act as a MCP client also, or it can act as a MCP server also. So when I say like MCP client, so connecting to the external MCP servers to use their tools. And when I say like the MCP servers, so exposing your NAT tools to all the other AIs like Claude, Desktop, or like the Cursor ID can use them. So, like if I had to write this like in a workflow dot YAML, so it looks something like this. So where we have like GitHub tools we have provided, we have a transport layer, we have a auth token, right? So this is, and uh, so coming to the agent to agent protocol. So agent to agent protocol is a kind of a AI agent to discover and communicate with other AI agents. So even those built like by different teams or companies, and A2A server publishes like a agent card describing its name, capabilities, and like how to interact with. So, like the key difference between MCP from key difference from MCP to MCP is about like functions. All about calling functions like a simple step, single step operations, and agent to agent is about delegating to agents. Like autonomous system can like handle like the handle like complex multi-step tasks. So if MCP is a phone call, so agent A2A is a hiring contractor, you can say. So that's what exactly A2A protocol means. And yeah, so let's now cover like industry use cases. Uh, like coming to the industry use cases, so I think like there are a lot many use cases for this. So like a real world application of an ad across the industries with a specific agents, tools, and like the NAT features each one uses. So understanding the use cases pattern. So every NAT uh, use case follows with the same basic pattern, like a complex business problem that requires like a gathering information from the multiple sources, right? And reasoning about it and taking one or more actions. So the pattern that would traditionally require like the team of people, and like the days of work can be handled by the NAT agent in a seconds. So imagine like for example like intelligent customer support for the e-commerce, right? So like the problem is like maybe like the mid-size e-commerce company receives like the 5,000 support tickets and per day. Like the human agents also it handles like one each one, looking up like the order status, checking like the return policy, maybe like pre-processing like the refunds eligibility criteria, right? So like the routine work that takes like 8 to 10 minutes per ticket maybe. So NAT solution, it's kind of a, like the router agents receives all tickets, classify them by, like the type, maybe like the order inquiry, or maybe like so think it of a kind of a routing agent on the top, right? So like a order inquiry, return request, complaints, etc., right? We can put them in the routing agent, and then a specialist React agent handle each type. So using like the tools to query like the order management system, click the return policy knowledge base, trigger like the refund workflows in the pattern in the payment system. The agent resolve like 78% of the, maybe like 75 to 80% of the tickets without human involvement, escalating only when there's a genuine exceptions, right? So um, so similarly, we can use that for the financial resource assistant, like an investment firm, like analyst spends like a 3 to 4 hours per morning gathering like the data, reading and earning reports, checking news, things like that. So like if we had like the NAT solution, like the analyst ask, like brief me on NVIDIA for our maybe like a 9 a.m. meeting, right? So the React agent calls like the stock prices API, search the recent and earning reports, queries, and like news sources, retrieves like the firm's internal research notes via RAG maybe, and or then kind of a synthesize like the structured like a briefing that covers like the financial metric, like a recent news, or maybe like analyst or like what is the risk factor within maybe like 30 seconds or like 40 seconds, more less than that, I would say. So similarly, in the medical record summarization or like the code review automation, things like that. Uh, and I think like these are the common, like the use cases, like a supply chain, learning tutor. Similarly, all you can apply them in all the industries. So it's kind of applicable everywhere. Like maybe in a real estate market analysis also, right? Recently, there is a security, like the threat intelligence SOC team has also started adopting uh, like these kind of like the NAT solutions, I would say. So initially, for example, like the security operations center receives like the thousands of alerts per day. So analysts must manually investigate, like each and every alert. So like checking logs, checking, going through the events, and like going to the database, correlating those events with the like the alerts or the loggings, and then like the alert fatigue like leads to the real thread like that might miss. So like when it comes to the NAT solution, it's like 24/7 monitoring. Agents receive like the alerts, auto correlate like with the thread intelligence feeds, and so many more things. So all with one particular solution. uh yeah, I think we have covered most of the things. So I think like also when to use NAT, what should be the decision frameworks, and so like going into the production with a real user, we can use NAT. Multiple agents, we can use NAT. Enterprise compliant, we can use NAT, right? So I think like we covered this particular thing. So five things to know before your first NAT project, I would say. So it's primarily like first is like the tool doc string, that is very critical, that we said, that we discussed. The next is like the temperature for the tool calling should be kind of a zero, because like we often use like the temperature zero for whenever we require some deterministic behavior. So always set like the max iterations. Like an agent without iteration limit can loop forever, so burning API credits with no ends, and default is set 10. So set it, that's for your safety, so that you don't run out of like the token, and you doesn't feel there is a cost explosion that is happening. And return like errors as a data, not exceptions. And also never hard code like the secrets. That's standard practice. So yeah, I think like these are first like we have covered up like the theoretical part. Now I'll just show you like how exactly we kind of like set up like the like a small demo. I will show you so that you get a idea like how we set up like the NAT pipeline or something. So any questions till now? Anyone? Okay, I'll take it as a no. So yeah, so let's start with like I'll try to cover it as quickly just to show you what exactly how exactly do we set up things. I know like you we're running out of time, so the first thing is like we understood like what exactly happened. So how to start with the NAT. So it's a kind of a framework that we use for building AI agents and workflows. So what happens is like first thing is like uh, we whatever comes in a config YAML file, like there's a NAT runtime, and then like followed by like there's a LLM, there's tools, there's agent loops, and then there is a response. So uh, um, mm, what we can make right now, I can just think. Uh, yeah, maybe we can just build something like for the chat and how are we like a simple chat. Okay, cool. So we can have like the different config uh, YAML files. So let's say for example we this is as a chat YAML. Okay, so we can create a folder for this, maybe configs. Configs, sorry, I want to know. And within this, we can make some file, maybe like a chat.yaml. So, yeah. So like this, we can make like we can create. So this is basically the chat.yaml that we have created. So we have used like a OpenKI for as a type, and this is gonna be like the endpoint that we are hitting. So I have got my own NVIDIA API key. So you guys can go to the developers account of the NVIDIA and try to generate your key and store it in .env file. And the next thing is like we can have one like main.py file, which could be the entry point for us. So uh, let's make it main.py, and in main.py, like the idea is like we can give we can assume like the argument should that takes kind of a command line argument, and like one should be like the config file path and other should be a query path, and there has to be a one environment variable also. So maybe we can have like .env, where you would be uh, like pasting your NVIDIA API key, and in the main function, we can have, yeah. We can import like the my tools. We can import like my tools. We can also call like the load workflows. We can call like a session managers that runs like the queries, and then we can return like the result. So let's first do the specific imports. And so this is basically for the load workflow. Uh, and then next we can like we can use the session manager like to load workflow that loads the config path that we are passing as a command line argument. uh, and this will kind of a build like most of the things. uh, then there should be a like run that kind of a runs on the query that we have given. So and then there would be a result that would be returning. So that returns the answer. uh, so I think this is something that uh, that could be for the main.py. And likewise we can create some sort of like the tools config also. So like for example, tools dot yaml, right? So maybe for example, if we want the llms, like what should be the llm, that should be the OpenAI, what should be the base URL like we had for like the chat YAML, right? So similarly we can have for this function like the tools also. So like we can have like the custom tools for this. So like if you see, there is a the functions that we have created is a kind of a calculator, that's a type that we have. The type is calculator. There's a converter that we were discussing over the slides also, right? So so how actually, so are the kind of a custom tool definition. So this file defines like all the custom tools across, like across the example. So every tool has, like the three patterns. So like there has to be a config class, that, and there has to be a registered function, there has to be an inner like async function. So that's how basically like a like NAT tool kind of a register like a works. So if you have seen in the previous slides, there was a tool decorator function that we ideally call, and any function could be registered with the NAT tool. So likewise, we kind of create those functions, and then we kind of make them as a allow them as a decorator functions. uh, Similarly we can have like react like a agent also, like whatever is the use case that we have, whatever strategies we are following up, right? So we can have similar sort of uh, like a YAML files, and based on those YAML files, like we are gonna like run those. Those would be passed as would be the starting point, I would say, for any of the NAT to like go through those. So then uh, there has to be like in order to register functions. So I'll show you the example how do we actually register functions. So for example, uh, so this is how we actually register those functions. So, for example, like there's a calculator tool that we have, right? So we have made like we have given like the proper doc string around them, like how to evaluate this. And then there's also like the safety evaluation that we are doing. So this is just like a normal, like a Python function that we have. So but again, we can also integrate like the APIs, external APIs also as a part of this. So yeah. So I'll I know like we are running out of time. I'm just replicate this particular repo. I have one particular code base. I'll show you how actually it runs. So just a moment. So yeah. So like everything is set up over here. So I'm just trying to run maybe like, for example, this I have chosen this config file as a router.yaml, the config, and this is like the question that I want to ask. So it's gonna respond me. So you here you see the answer response that I got. So like that's a response from that. So it has gone through this, taken as this as a parameter, and this is a query. So that just a basic implementation of like how actually like that works. So there's like everything could be, like traced, like whatever that you're using, like a open telemetry for the tracing. So like similarly, if we want any other agent, we can use any other agent, like there are a set of different agents that we have. So maybe for the chat, if you want, we have this. So we have kept the temperature as zero point 0.7, so that means it's bit non-deterministic. It can come up with different, you know like uh, uh, like for example, like explain like the computer vision in the two sentence. So if the temperature is zero point 0.7, right, so it will probably give us the different answer in every different hit that we have. It's taking some time. Oh, it's taking some more time than expectation. So but similarly, like I hope you got the use case. How do we actually use this? Something might have went wrong, or maybe I might have run out of my credits, possibly. So yeah, that's a bit about like today's session. And yep, now I know like we are running out of time, so I'll just give few minutes to you guys. uh, if you have any questions, anything, we can just discuss. Or anyone, any question? I'll share with you guys like this particular slides after the session, and maybe some material for the like for your practical, like a lab kind of session, so that maybe like a Jupyter notebook, so that you guys can run and see it on your side, like if how does it works. Anyone, any question? So ID that I was using was like cursor.
Is it the free tool like we can use without paying?
Uh, I guess like you get some basic like the models that you can just use on the cursor for the auto completion or anything. So basic version I think like you can use, but again like there if you want some like better models or anything you might have to pay for that.
Yeah, okay, got it.
Yeah.
And how can we use these for automotive testing domain for the software testing, like using these agents? I'm working at automotive domain for one of the OEMs. I just wanted to know how I can implement these in the testing.
uh So specifically, this Nemo agentic toolkit, I think like there could be various ways that you can try to implement them, uh, like for automotive testing. So like like the test case generation, you can like try to build like agents like read the requirements or like specification, like can how understand what are the autos are kind of configs, and like generate like the test cases automatically. So maybe like the example flow could be like a requirement doc comes like ADAS, like anything, right? So like the agent pipeline has to be like a requirement parser kind of agent you can create. You there could be followed up by the scenario generation agent, and then there could be separate like the test script generation agent, and then like the validation agent. So like based on your use case you can try to break down your work into the separate like the segments, and try to create those custom agents for
Agents.
specific use cases. Yeah.
Okay, okay. I can integrate the custom tools also, right? Like Canoi simulation tool and hill testing related vector tools into the execution using these agents, right?
uh yeah, so I think like any of the like you can add as many as you like you want to add like the custom tools like a simulation
Okay,
tool, anything. Yeah, so it depends on your specific use case.
okay. I think the cost will be a little high if I use more agents, like based on the GPT, right?
So,
Based on
so,
the
so
LLMs
like
that used.
like I said,
This meeting is being
we kind of
recorded.
we can use some cheaper models, right?
Okay,
And then for some some complex workflows that requires a lot of reasoning and things like that, so that for you can go for some better models. So it's not like you always have to use like same model for most of all the cases. It's like depending on you, like how you are optimizing those costs based on like your use case.
okay,
For simpler tasks you can use some very simple models as well, or maybe you can also build some smaller classifier on the top rather than relying on the specific LLM. You can also build a in-house simple intent classifier kind of stuff also.
okay, okay.
Yeah.
Thank you.
Anyone else? Any other question? Yeah, if not, like maybe we can close the session, and I'll share with you guys like this slide and any other like material if I find helpful. I'll share that towards chat or maybe with Insha. Cool. Thank you guys for joining. Have a good rest of the day. Thank you. Bye bye.
Thank you.
The recording has stopped.